From renewable energy and sustainability to designing buildings safely, the nature of light has many implications in engineering. But how complicated can this be? I mean, light is just an electromagnetic wave, right? After all, it can be reflected off smooth surfaces, refracted as it passes through different mediums, and diffracted as it passes around objects or through small openings, just like any other wave. Monochromatic light produces interference patterns when it is shone through two slits at a screen. It can be polarized by polaroid filters, and it undergoes the Doppler effect. These are more proofs for wave light. But in 1887, Heinrich Hertz, of frequency fame, noticed when ultraviolet light hit electrodes in a vacuum, a current was recorded. This is due to electrons on the metal surface receiving enough energy from the light to escape the metallic bonds. Those that reached the opposite electrode caused a current in the wires. But if light is a wave, it shouldn't matter how much energy it had. Eventually, an electron should absorb enough energy to escape. But for frequencies of light less than ultraviolet, there was no current. No matter the intensity of the light, there was also no time delay. Even if the UV light was very dim, as soon as it hit the electrode, a current was recorded. In 1905, Albert Einstein theorized that light energy is carried in separate particles called photons. The energy of the photon is directly proportional to the frequency of the light. It takes a specific amount of energy, known as the work function, to remove an electron from its metal. Only when light is of the frequency greater than this threshold frequency will the electrons have enough energy to escape. The greater the frequency, the more energy the electron has after escaping, and it flies off with greater kinetic energy. Electrons will only absorb the energy from a single photon, so if it doesn't get enough energy to escape, it will re-emit the energy as another photon. Imagine a ball against a step. You can push it with all the little pushes you like, and as many of them per second as you want, but until one big push with enough force to get it over the step comes along, it isn't going anywhere.